Nothing in the universe can match the mysterious and remarkable organ we call the human brain. From its tiny cell structure, the neuron, to the folded convolutions which lie within our skull, our brain has made us masters of the earth. And soon, we may be masters of our mind as well.
You're doing very well. Open your eyes now.
Today, researchers study the electrical and chemical nature of our brains to uncover the secrets of intelligence, emotion, disease, and even creation.
Relax now.
They probe with sensitive electrodes. They observe the workings of animal brain systems. And they explore with surgery the hidden corridors of this intricate inner space. This research will help us better understand how the brain functions. In time, our knowledge will give us the power to understand not only our brains, but the human qualities which make people so unique. The mass of organs and tissues we call the human body is a unique and complex machine. With it, we are able to move. We can breathe life-sustaining air and see the world around us. We are able to think, consider possibilities, and go a different route if we so choose. These things and more are regulated by an essential structure in the body we call the master organ, our brain. Hundreds of years ago, our heart was thought to be the master organ. Cupid's arrow was aimed at our hearts, not our heads, and the brain was considered only a cooling place for the blood. In 450 BC, the Greek philosopher Hippocrates gave far more value to this bone-encased tissue. He reasoned that from our brains came feelings of love, joy, and pleasure, as well as our sorrow, grief, and tears. As scientists began to further explore the nervous system, they realized that nerve cells were linked by our spinal cord to the brain. It was thought that nerves brought data to and from the brain, but just how this information transfer occurred, no one knew. In 1764, Italian Luigi Galvani used electricity to explain this nerve impulse phenomenon. His experiments with frogs' legs proved that tiny currents were responsible for movements in animals. He called this current animal electricity and claimed that the brain in living animals was the center of this activity. In 1893, Spanish scientist Ramon y Cajal used a microscope to study the brain on a cellular level. He observed a mass of intertwining nerves, contacting one another by fibrous strands called axons and dendrites. It was along these pathways that impulses which govern the functions of our bodies traveled. As our knowledge of the brain increased, scientists began to appreciate how different sections of the brain controlled different functions. The brainstem, an irregular column about 3 inches long, was found to contain a center for our autonomic nervous system. It is here that such unconscious activities as heartbeat, respiration, and digestion are regulated. Attached to the rear of the brainstem, a symmetrical structure called the cerebellum was discovered. It functions to coordinate and synchronize our muscles, making our movements steady, smooth, and efficient. Overlapping both cerebellum and brainstem is a large mass called the cerebrum. Here were discovered areas related to the operation of our 5 senses. This section is also considered the seat of consciousness, playing a major role in thought, personality, and intelligence. Our historical studies have revealed that the brain is both an electrical and a chemical machine. Today, with the help of man-made machines, we can learn more about its electrical functions. One of these devices is the electroencephalograph, or EEG.
Again, going back like the ocean, your brain makes waves, but the waves it makes are very much smaller. In fact, they're only millionths of a volt. So they have to be amplified to be seen. And what an EEG machine does is amplify those waves so you can see them and write them out. And if you examine the waves, we see that they are complex waves, very difficult for your eye to resolve. Visually looking at a brainwave recording, electroencephalographers now know the difference between normal and abnormal recordings. And in normal recordings, we can tell a awake, alert person from a relaxed inattention state to a drowsy state through the stages of sleep. And in abnormal recordings, with ordinary electrodes, we can get quite good signals from a person behaving even during the course of an epileptic seizure. We can capture the seizure signal.
Machines can also help in treating brain disorders. This woman's condition was so critical that conventional operations and drugs were unhelpful. For her, hope lay with a new electrical device nicknamed the brain pacemaker.
The actual physical tool consists of a thin silicone plate which carries on one of its surfaces small platinum electrodes. And this is placed on the surface of the cerebellum after that has been exposed surgically. And the wire coming from the electrodes goes under the skin to a small power pack under the skin of the chest. And all of that then is inside the body.
The brain pacemaker continuously delivers a small electrical stimulation to the area of the brain controlling muscle coordination. As a result, the erratic movements associated with disorders like epilepsy and Parkinson's disease are often eliminated. We are not sure why it works, but the results are encouraging.
We've had a few patients who were on the verge of death from continued seizures. They simply could not be controlled, and they're now controlled, so that was successful. On the other hand, I don't pretend that it's a cure for epilepsy. It's a method of treatment which helps some types that can't be helped any other way.
In this case, electrical stimulation of the brain was successful, and the patient was able to lead a more normal life. We rarely notice the remarkable role our brain plays in coordinating the events of our daily life. Our brain enables us to walk with unconscious grace. We can interpret and respond to the people, places, and things around us. We can even share feelings of warmth and companionship, all due to the incredible 3-pound mass of cells in our head. But did we know that everything we think, feel, and do is dependent upon the chemicals within our brains? In a normal brain, 3 billion nerve cells are stimulated each second with minute quantities of electrochemical energy. By slowing these impulses down and representing just 2 cells, we can better understand how chemicals affect electrical impulses. The journey of an impulse through nerve tissue begins at the receiver end of a neuron called the dendrite. When stimulated, the receiver dendrite transfers its signal to the cell body and finally outward along a fibrous strand called an axon. Near the axon's terminal end, the impulse comes to a junction between cells called the synapse. Shown here with arrows, the synapse is a fine gap that separates nerve cells. It is at the synapse where electrical impulses are affected by chemicals in the brain. Some chemicals will stop an electrical impulse. Others will aid in the passing of that impulse to another cell. Since chemicals within the body affect electrical impulses, it should not be surprising that some chemicals which we take into our bodies can also affect the functioning of our brain. These substances, like alcohol, are commonly called mind-altering or psychoactive drugs. In 1943, Swiss chemist Albert Hofmann accidentally swallowed a substance he had been working with in his laboratory. The effect was immediate and overpowering. The drug was LSD.
I lost all control of time. Space and time became disorganized, and I was overcome with fears that I was going crazy. There surged upon me a stream of fantastic images of extraordinary plasticity. Sometimes I shouted or babbled meaningless words. I felt as being outside my body. I thought I had died.
Hoffman's feelings of disorganization are similar to the hangovers of many alcoholics. Alcohol affects the nervous system by slowing down the normal functions of our brain. Enough alcohol, and we become unconscious. A stimulant like Dexedrine has much the opposite effect of alcohol. It causes increased cerebral excitement, higher blood pressure, and a mental desire to move faster than normal. Clearly, chemicals in many forms can and do affect our brains.
Now let's see. Things to memorize. The vowels are A, E, I, O, U. The consonants are, consonants?
Even with modern technology, some mysteries of the brain lie untouched. We still don't understand what consciousness is. We cannot fully comprehend how some parts of the brain function. But while scientists work on these problems, one subject remains the most baffling and challenging of them all. This involves the unique nature of our memory. For given all the years of study, researchers have not yet discovered how or why we remember.
Now I got it. Why didn't I think of that before?
In 1923, psychologist Carl Lashley began to search for the smallest unit of memory. Lashley searched the cerebrum of rats and men for 30 years, looking for that one area where thoughts were stored. He never found it.
In reviewing my evidence on the memory trace, I sometimes come to the conclusion that memory is just not possible.
Today, researchers continue Lashley's work in pursuit of the elusive memory trace. Some believe that the key to memory lies in chemicals. These men probe the 20 trillion pieces of nucleic chemicals, like DNA and RNA, in search of memory. Others explore electrical circuits in the brain for clues to memory. One area presently being studied is the hippocampus. It has been the subject of animal testing at the University of California, Irvine.
The brain is shaped sort of like a rounded football with two large structures called the temporal lobes coming out below. The hippocampus in each side is buried in the temporal lobe. It's buried in the depths of the brain, on each side of the brain. We have a feeling now from a lot of different sources of evidence that the hippocampus seems to play a very special role in learning and memory.
Dr. Thompson's research involves recording the electrical activity from rabbits' hippocampus during a memory experiment. Electrodes painlessly implanted in the rabbit's skull allow the activity from the hippocampus to be registered on an oscilloscope. When a tone is heard through a speaker, the rabbit reacts by blinking his eye. In this way, the rabbit avoids a slightly irritating air puff on the eyeball, which immediately follows the tone. Before the animal was taught to blink, the activity in the hippocampus was small. Now, when the tone is heard, and the animal remembers to blink, the activity in the hippocampus rises sharply. This increase suggests that the hippocampus is part of the memory system.
As far as we can tell, the hippocampus is the first place in the brain where memories begin to form. They begin to develop almost immediately in the hippocampus. It then serves to take this developing information and store it more permanently in other brain systems. It acts as an executive to take this information, recognize it, store it, and then retrieve it when the organism needs to remember something.
Modern scientists have come a long way since the days of these crude operations, and as future techniques improve, the mysteries of the brain will be solved. But some people fear that future brain researchers may probe too far with their advanced techniques. They suspect that too much knowledge about thought processes might encourage electrode implants to control thought, thereby creating human robots. They believe that if our chemical technology is not closely watched, the soldiers of one country might try to pacify their enemies with a mind drug, or that we might pacify ourselves with one. Although much still remains unknown, researchers have begun to unravel the mysteries of the brain. Scientists present mankind with new possibilities for the enhancement of life. They develop techniques to electrically control brain disorders, as with epilepsy. They tantalize us with the possibility of changing our awareness with a chemical, and of learning the secrets of human consciousness and memory. These advances will have a profound effect upon the lives of all of us, for by understanding our brains, we come one step closer to a better and fuller knowledge of ourselves.